Given the rational function r of x equals negative 2 over x squared minus 5x plus 6, find the vertical and horizontal asymptote, the x-intercept and the y-intercept. Okay, so here's how we find these asymptotes. For the horizontal asymptote, I'll do it over here. We first compare the degrees. The degree of the top, in this case, is a 0-degree polynomial. We're going to compare that to the degree of the bottom, which is a second-degree polynomial. So it turns out that the top degree is less than the bottom degree. So according to our note, that means that y equals 0 represents the equation of the horizontal asymptote. Now it's easier, I think, to find the vertical asymptote. You just set the denominator equal to 0, factor, and solve. So when we factor it, we get x minus 2 times x minus 3, set the factors equal to 0 and solve. We get two equations for the vertical asymptotes. These are equations of lines, x equals 2 and x equals 3. They're not points, they're not just x values, they're equations of lines in the xy coordinate system. Okay, now we're going to consider the x-intercept. You always find x-intercepts by letting y equals 0 and solving for x. So in that case, we're going to let r of x, which is our y value, equal 0, and have it equal to our rational function negative 2 over x squared minus 5x plus 6. Okay, so that implies that the top is equal to, well, we're going to set the top equal to 0. What I'm saying is that a fraction cannot be 0 unless the top is 0. In this case, negative 2 is on the top. So I'm saying for this fraction to equal 0, the top negative 2 must be equal to 0. But that's nonsense, so there's no x-intercept. Negative 2 is not equal to 0, it's equal to itself. For the y-intercept, I let x equal 0 and solve for y. So r of 0 equals negative 2 on top over 0 minus 0 plus 6, so it's negative 2 over 6, which simplifies to negative 1/3, and that gives me the y-intercept ordered pair xy equals 0, comma, negative 1/3. You know, I could take all of this information and make something of it in a graph, which will make it really easy for me later on when I graph these things. I could draw these values where the asymptotes are, and I could draw the horizontal asymptote, I could draw the x-intercept and the y-intercept, and then it was a really short, quick exercise to finish the graph, which I'm not doing here because we're not quite ready for it, but we will be doing it soon. This is what all of this work is for, to get us ready to graph rational functions.